So, hello and welcome everyone. So, good evening. So, can I get a confirmation in the chat box if my voice is audible clearly or not? So, can I get a quick confirmation in the chat box? We'll be starting the session soon enough, like within a minute or something like that. Okay. Thank you, Rishit, for the confirmation. So, what do you think about today's problem of the day? Was it good enough? Like, did it require lots of brainstorming and then eventually you arrived at the right solution? Hello, hello, hi. Toxic things. Hello, hello. So, how many of you were able to solve the today's problem of the day? Okay, Akash says it was challenging. Okay, okay. And what about Rishit and other people? Share your experiences. I would like to know your experiences as well. Okay, I'll read out the comments afterwards. So now let's start the today's problem of the day. So let me share my screen. So 27th March, the problem of the day is divide in incremental groups, and it was asked in Expedia according to the information provided over here, right? So first of all, let's try to read out the problem statement. Okay, I got an answer that it was hard, challenging. Okay, yes. So let me just change the layout. Okay. So first of all, let's try to understand the problem statement. Okay, so the problem statement seems a little bit difficult to understand, I think, because there are lots of numericals like inequality and all that. So let's understand. So given two integers n and k, the task is to count the number of ways to divide n into k positive groups. So that means there are n number of integers starting from 1 to n. Divide in such a k number of groups. You have to divide those numbers into k groups of positive integers, such a way that the sum of all that integers in the specific group is equal to n, and the number of elements in groups follow a non descending order. That means the number of elements should be in increasing order. So that's like an extra thing provided, but that's not at all required because you can arrange the groups in an ascending order afterwards as well. So that point is of no use right now. So now let's think about the input test case. So let me explain with the help of an input test case. So n is equal to 8 and k is equal to 5. So this is the input number 1 given to us in the question. So the question says that you have to divide all the numbers from 1 to n. You can pick any number from 1 to n, and you have to create a group of k integers. That means the group contains only 5 integers. And what you have to do, you have to create such a group that their sum is equal to n. That means the elements in the group should add up to 8. Okay, and over here you can pick the same element multiple number of times. Let me start and explain one of the groups. Let's say I am picking 1, and then let's say I am taking 1 again. So that means 1 plus 1, that would be 2. So I still need 6. So what I'll be doing, I'll be taking 3. Let's say I'll be taking 2. Let's say 1, right? And I'll be taking 2 and again a 2. So the sum of all the integers is equal to 8. 2 plus 2, 4, 5, 6, 7. Or let me say over here, I need one more 2, right? So 3 2s are 6 and 1 plus 1, 2, 8, right? So the sum of the elements in the group is equal to 8. So you have to create such a groups. So in total, you have to find out that how many such groups are possible. I got one of the group G1, you'll be getting another group G2, you'll be getting another group G3, and so on. and let's say you will be getting another group GM. So you have to count how many groups are possible in total. So that is the question. Was the question clear to everyone? A quick confirmation in the chat box. Today in general, I'll be having three different approaches, starting from the basic to the mediocre one and the most optimal one. So I'll be explaining everything quickly. So I'll be needing the confirmation very quickly. A quick response from everyone, yes or no, in the chat box. Okay. So that is what we have to do. So for this input number one, the output given to us is equal to, let's see what is the output. It is equal to 5. And what all different groups are possible? So here the groups are given that this is for k is equal to 4 and n is equal to 8. I was explaining for n is equal to 8 and k is equal to 4. For that you will be having a different answer, and for n is equal to 8 and k is equal to 4, you are having 5. So all the groups contain, let's see what are the groups, 111 and 5. So that adds up to 5 plus 3 8, 1124, 1133, 1223 and 4 times 2. So these are the 5 different groups which are of k size, and that adds up to n. So this is the entire question. So for given n and k, you have to find out the output and print out the output. So that is the entire question. And let's take a look at the constraint as well. So the constraint says that the maximum number can reach till the value 100. K can be 100 and n can be 100 in the worst case. Okay. So from this you can get an idea that an n square approach will be feasible, because n square would be 10 to the power 2 into 10 to the power 2, that would be 10 to the power 4 iterations. So from this I can get an idea that n square approach is applicable over here. Was this observation clear to everyone? So whenever you see hard questions, do not skip the constraints part, because that would give you more clarity on in which direction you can think, right? Dark mode. Okay, I'm not having that extension over here. So okay, so I think it's over here. Till then, can I get confirmation from everyone that was this observation clear or not? So where is the dark mode? So let's leave that part right now. So I think everything was clear. So I can go in the direction where the approach can be n square. Okay, so that is about the optimal approach which I can think of. Right, so first of all, I need to come up with a basic solution, that what can be the solution for any given n and k. It doesn't mean that I need the optimal one every time. I can simply think of an approach that can lead me in the right direction, that can help me to get some of the approach. A single approach is also valid because I'll be able to solve the question. At least that is possible, right? Okay, near the new languages. Let it be, yeah. Okay. Okay, so I'll be getting the idea that I can go in that direction. So we'll be discussing the brute force approach. What can be the brute force approach? So let's think about the brute force approach. So first of all, I need to think in terms of n, what arrangements are possible. For n is equal to 8 and k is equal to 4, I came to know that the output comes out to be 5, right? But there are hidden entities over here. So the question says that you have all the integers from 1 to n. 5, 6, 7 and 8. And from all these integers, you have to form such a group that the size of that group is k, and the sum of that group is equal to what? It is equal to n, and n means what? It is equal to 8. So these are the hidden entities, these are the hidden integers which you need to figure out from the test case. Okay, so from this I can think of an array, or let's say a range of integers from which I can select something. So can I form a solution in this manner? So what I'll be doing, I am having this many numbers. So I can say that in a group, I can include this number or I can exclude this number. While forming the group, I have two possibilities for each and every number. Either I can include it in my group or I can exclude it from my group. Is this part clear? I have two options for each and every number, either to include in a group or to exclude from that group. Is this part clear or not? Let's say I'm forming a group, and in that group I was trying to get a number. So for this one, I have an option that I can include it or I can exclude it. Okay. So these are the two possibilities for this question, for this number. So for each and every number, I have two possibilities. Either I can include it or I can exclude it. But how many times can you include a number? So you can only include the numbers k number of times. Include only k numbers. Okay. So if I'm including 1, I'm excluding 2, 3, 4, I'm including 4, I'm including 5, again 4. So I have included four integers in total, right? So the group was 1, 4, 4, and 5. So if I'm iterating over these numbers, range again, then I cannot select any of this number because it will not be acceptable, because the size of the group is restricted to be k. So that is the reason I can only include k number of integers from this range. So what I can think, for any element, for any integer, let's say for any element integer, I'll be calling this elements. Okay. So for any element, I have two options. I can include it or I can exclude it. So what can be the condition to include in the group? If I want to include an element, what can be the condition? And what can be the condition if I want to exclude the element from the group? So the question says that for each and every group, the sum is going to be equal to n. Okay. So what I'll be doing, I'll be working in the backwards direction, that I want the group to have sum equal to n. So what I'll be doing, I'll be including the elements and I'll be decreasing the size or the capacity of the group. Let's say the group sum needs to be 8. So what I'll be doing, if I'm including 1, so I'll be saying that 1 has been included. So now my group sum should be equal to 7, in that manner. To include element is remaining, yes, remaining sum to become equal to n. Yes, exactly. So if I am excluding the element, that means that the element will be greater than the remaining sum of the group. While forming the group, I'll be decreasing the value of my sum variable, and whatever is the remaining value, if that element you are considering is having a value greater than the remaining sum of the group, I will exclude that number. So this is the condition for excluding. And if the value is lesser than the remaining sum of group, then I can include it. So over here as well, you have two options. It is your choice to include it or you can exclude it as well, right? Because I can include it if I want, and if it is giving my feasible answer, then I'll be including it in my group or I will be excluding it. It's my choice. I can have this many options. Is this choice diagram clear to everyone? A quick confirmation from everyone. I'm not getting confirmation from everyone. I'll be getting an idea that you all are able to understand it properly, because this is the basic thing we need to. This is like the base of the entire solution. We need clear idea, clear understanding on this base. Based on this, we'll be deriving all the solutions. A quick confirmation. Okay, +1 in the chat box. That's really good. Okay. So this is the choice diagram, that for each and every element, I will be having this many options. So I can think of a recursive approach, because I'll be working on the remaining sum of the group. Each and every time I'll be having a different set of integers and I'll be having a different sum of the group, because the remaining sum of the group has been included now. So I'll be having different sub problems and I need to solve different sub problems, and from all the sub problems I need to get the count of total groups. So what I'll be doing, I can think of a recursive approach because I have different sub problems that can be solved in the similar way. So I can think of a recursive approach. And over here you are having two options, include or exclusion. So that can be easily done with the help of recursion, this implementation part, right? And over here, this choice diagram is the body of the recursion. This denotes the recursion function call, where you will be making a call with which entities and with which values a function call will be made. So over here, if you observe carefully, the function call will be made at this part, and this part at leaf nodes of this choice diagram. So I have three different values. I have one variable that is called sum, and this denotes the remaining sum of the group. I have the size of the group, that is k, that is the maximum size, and I have the integers 1 to n. So over here I'm only noting the value of n, because what I'll be doing, if let's say I'm having the maximum value of n, let's say the n value given to us is 8. So what I'll be doing, first of all I'll be choosing this last number 8. Then in the next option, what I'll be doing, I'll be decreasing the value of n. So I'll be passing the argument n minus 1. So I'll be getting another element of this range. So in that way you can avoid using any extra arrays, right? As this is a consecutive range, so this thing can be done over here. So let's say if I'm including the element, I know that the condition should be that whatever element is that, the n is the element. If the value of that element is greater than the remaining sum, I will be excluding that element. So if you are excluding the element, you will be making a function call. You will be making a function call, and these are the arguments of the function call. Okay, I'm noting down over here. From this we'll be getting the recursive function. So when I am saying that n value is greater than sum, I will not be including that element in my sum. So including the element in the sum means that I will be decreasing the value of sum by selecting that element. So if I'm not including, the sum value remains as it is. Okay, if I'm not including, the sum value remains as it is, and the size of the group also remains as it is. Okay, and what about the integer n? So if this condition is satisfied, then this integer n is of no use, so I can exclude it. So I'll be moving to the other element. So I'll be, as I'm moving from 8 to 7, so I'm decreasing the value of n. If this is my n, I'll be doing n minus 1 to get the value of 7. So this is the function call I'll be making if I'm excluding that element from the group. Is it clear? Yes or no in the chat box for this part? A quick yes or no in the chat box. Okay, so this is the function call to exclude the element. Now over here, let's move on the left hand side. If I'm including the element, what does it mean? See, I said that if I'm including the element, then that means I'll be decreasing the remaining sum of the group by n. Okay, so I can see the difference I'll be passing will be sum minus n for sum remaining sum of the group. So this will be our new remaining sum of the group. And if I'm including the element, I'll be decreasing the size of the group, because I have only k minus 1 elements space remaining in my group. Let's say if the group size was equal to 4, and if I'm including one element, then now let's say this element is included. So what is the size remaining? It is k minus 1, right? So this is the size remaining of the group. And if I'm including the element, I have two options. If I'm including the element, I can include the element again and again, and I can include the next element. Let's say, as I mentioned, that there is possibility that you are supposed to include that element. You can include the element multiple times in the group. Okay, and due to that condition, what you can do, if you are including that element, you can again make a recursive function call with that same element. You are trying that if I want to include the same element in the group, is it possible to generate such a group or not? Okay, same as 01 knapsack, not 01 knapsack. This is exact similar to coin change problem, in which you need to give a change of some amount, and you have this many number of coins, and you can select that coin multiple number of times. This is exact variation of the standard problem, coin change problem. Was anyone able to figure that out or not? If you have you done a coin change problem, it is the DP standard problem. How many of you have gone through that question? How many of you have done that question, coin change problem, the standard DP problem, similar to critical classical coin change? Yes, 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 Akash, exactly. So I can select that element again and again. So I'll be not decreasing the value of n. Sorry, I think the screen sharing has been stopped. Okay, so I can pass the argument n element, this element as it is. Just a minute. Okay, it's fine. So if I can include the element again and again, if it is possible, I can include the element again. And if I want to exclude that element, that means after including that element, I'll be moving towards a new element. That means I'm including the element, so sum will be decreased by n, and the size of the group will also be decreased by 1, and I'll be moving towards a new element now. Okay, so that means I'm not including the element, but I have included and I'm moving towards a new element. So these are the three different function calls with two conditions. If the element value is lesser than, and if the element value is greater than, these are the function calls. And when you get an answer from this function call, if you get an answer from this function call and this function call, as you are including the element, if you are getting the answer, then that means you have got a valid group. So let's say if this is returning A and this is returning B, then what does it mean? The sum of this A and B is the answer. The sum of this A and B is the answer. If you have gone through coin change problem, you need to find out how many different ways you are able to give the change. You did this, you do the same thing. This is the same thing at, similar to that question. Okay, I'll be adding this. And now if I talk about the base condition, what can be the base condition? So the base condition can be that when, what is the condition? When you will be getting a valid answer. So when the remaining sum has been reduced down to 0, and also the size of the group is now 0, that means you have got a group that contains k integers and its sum is equal to n. So in that case, you can return 1. So that means I have got one valid group. This returning of 1 means I have got one valid group. Is it clear? Yes or no? A quick yes or no in the chat box. A quick yes or no in the chat box. I can see a lot of you are eager to learn this question, and I also really like this problem. It's a very good problem. So can I get a quick confirmation? Was this part clear? The base condition part. We need to add the value from the branch. No, it will be returning 0. Okay, so this condition, as you are not including that element, no, see this, yes, this will be also returning a value. This will also be returning a value, and that needs to be added to the final sum as well. So this is a recursive function call. It is possible that this function call was made from this parent. Okay, so this was the parent function call, and this function call was the child function call. It is possible. Okay, so for now you can take this value, and whatever value this element, this function call is returning, let's say C in this case, you will be returning that value as well. Okay, but you won't be adding A plus B plus C. You will be only adding A plus B. Okay, because both the values will not be derived at the same time. Only one of the condition is valid at a time. Either the element can be greater than the remaining sum or it can be lesser than the remaining sum. Okay. So this is the base condition. We have figured out the base condition. And when can be the answer 0? When do you think the answer is not at all possible? For the selected elements, if you are thinking to form a group, then you will not be able to get a group. So that condition would be, this is the base condition that would return 1. And now if in case, let's say, if the value of n has been reduced down to 0, that means there are no elements remaining. You cannot choose anything. And if the sum value is not equal to 0, there are no choice remaining, and the sum of the group is not equal to 0, then that means the group which you have got is equal to it is not a valid group, it is invalid group. So in that case, you will not include that element or that group's count. So that means you will be returning 0, because that group holds no value. If the group holds the value, I'll be returning 1, else I'll be returning 0. Right? So from this base condition, we can figure out the entire recursive function. So let's write down the recursive function. So the first argument is n, the next argument is the size of the group, remaining size of the group, and remaining sum of the group. Okay. And I'll be noting down the initial arguments, that initially the value of n will be passed, over here the value of k will be passed, and over here the value of n will be passed, because the sum of the group over here is mentioned that it should be equal to n. So I have passed the remaining group of remaining sum of the group to be n initially. Okay. So now I'll be writing down the base condition. So the base condition was, what was the base condition? Let's copy the entire base condition. So if the sum value has been reduced down to 0, so in that case it means I have got one valid group. And if the number of elements is equal to 0, that means I haven't got any choice. I don't have any choice. And sum is not equal to 0 yet, I'll be returning 0, because there are already k number of elements in the group and nothing can be done for that k elements. We feel sorry for those elements. So now I'll be writing down the entire choice diagram. This is called our choice diagram. So over here, I will be simply copying this thing. Okay. It will be very interesting to see that, okay, how we are converting it to entire function. So if the element, what is the element over here? According to the syntax, according to the variable names, n is the element. What is the remaining sum of the group? It is equal to sum. Let me write down, if n is lesser than sum, then what I'll be doing, I have two function calls to make. So that is one function call that will be including the element, and again it will be checking if I include the element once more, then what can be the possible number of groups. And if I am only including the element once, then what can be the possible output. Right? Nothing has been changed. Okay, you already understood this part, how I wrote this entire function, and now you are helping me, and you yourself are thinking, okay, so this is the entire puzzle kind of thing. Right? I think this is very interesting to uh, understand as well. So this both the functions will be returning and returning some value, and I'll be simply returning it as it is, whatever value is given. This denotes that this is the total count of groups possible. And the other condition for uh, n and sum is that the element is greater than sum. So that means n is greater than sum. So I can include it as a comment, because only if this condition is executed, then over here the control will not reach over here. If this condition is not executed, then and only then control will come over here. For that, what is the condition? What is the function call? So the function call is this. I will exclude that element, so the value of k and n, k remains as it is and the sum remains as it is. And now over here return the value. And this is the end of the function. And that's it. You already wrote down the entire uh, recursive solution for this one. For the second base case, we should check sum is not equal to 0 and not. No. So for the second base case is that you already have included k number of digits. You have included k number of digits, okay? So if you have included k number of elements, then your k value will be 0. And in this condition, the k value is 0. But if the sum value is not equal to 0, then the control will reach over here, and one of the condition will be satisfied. Okay. Mhm. Just a minute, let me confirm over here. Okay, the k value should be 0 and the sum value should not be it should be 0. Both of them should be 0. Okay. If both of them are 0, don't worry, I have written down the entire solution by myself and you won't get the editorial similar to this one. If the sum value is equal to 0 or the k value is equal to 0, then that means you cannot include that element in the group. You cannot include that the entire group as a valid solution. Okay, thanks for pointing it down, or we have made a mistake over here. Okay, but to know we have included key elements, then we should check. Yes, exactly, we should check. So I have written down this condition that if all the k elements are present and if the sum is not equal to 0, then that means this k equals to 0 condition will be satisfied, and then and only then return 0 will be executed. Okay, and if only the sum is equal to 0 and k is not equal to 0, then also this condition will be fulfilled and 0 will be returned from this point. Was it clear to everyone now? A quick confirmation in the chat box. Is it clear or not? Okay. So this is the entire brute force approach. So the brute force approach is using simple recursion. So now if I want to find that what can be the time complexity of this approach. So let's understand the size of the group. What was the size of the group? It was equal to k. And for each element, I can include the element multiple number of times. And over here, let's say k positions are available for each and every group. So let's find out how many total groups are possible in the worst case. Over here, at the first position, I have n number of elements. At the next position as well, I have n number of elements because I can choose that element multiple number of times. So these are the number of choices for k different elements in the group. And how many times do I have? How many number of elements will be there in worst case? So that means you are multiplying n how many times? K number of times. So the time complexity of this approach will be equal to n to the power k because you are trying out every possible group. So in total, n to the power k number of groups will be checked in worst case. So this is our time complexity for our brute force approach. And talking about the space complexity, so that depends upon the depth of the recursive function call. And in depth, how many, like what do you think, what can be the depth of this recursive function call? The recursive function call will go maximum of some value or the k value. If k value is equal, let's say if k is smaller than sum, then that means only k number of recursive function call will be made. Then either of this condition will be true. So the maximum of n and k, let's say we'll be taking maximum of n and k. So I'll be writing down n. So the space complexity in terms of recursive depthness, it is equal to order of n. If n is lesser than or equal to k, yes, n is lesser than or equal to sum. So that means the value can be equal to sum, that is equal to remaining sum remaining sum as well. Yes, you need to include that value as well, right? So this is the entire recursive function for this approach, for this entire question. Do you have any doubt in this part? Any doubt in this? Okay, minimum of sum n k. Yes, minimum of sum n k. That's correct. I think I said maximum, right? So it is minimum of sum n k obviously, because whoever is smaller, that will become zero sooner. So minimum of sum n k. If I think I spoke maximum, then I'm not like, it should be minimum. Okay, so now let's start and let's try to optimize this approach. Obviously this approach is not going to work, because if n is equal to 100, and over here it is given that the value of k can be lesser than or equal to n, and in the worst case it can be equivalent to 100. So let's say in the worst case, how many iterations will be there? 100 to the power 100, taking the value maximum value of n and k. So this will be a very large number, and obviously it won't be accepted for a big test case, right? So we need to optimize it. So the optimization can be done by simply memoizing the entire solution. Over here you can observe that different values are being function call will be done. It is possible that if you are seeing a group once, then you will be again reaching that same incident. If you draw a recursive function call for this one, let's say let's draw for n is equal to 8 and k is equal to 4. I think the recursive function call process will be very lengthier. But if you draw the recursive function call, then you will be able to find that at some point you are repeatedly making the same recursive function call, because it is possible that there are multiple groups you can get in the different manner. If you do like let's say a different choice at step number 1, and if you do this at and you will be reaching let's say group number 1 by doing a different choice, then that is possible, that can be reached in a different way as well. You will be able to reach group number 1 again as well in a different path. So some recursive function calls will be repeated over here. You can explore that by drawing the recursive tree, and you'll be able to observe for a smaller test case. Take a smaller test case, you'll be able to observe it. So there can be some memoization done, that if for this n, k and some value, again a recursive function call will be made. I will be not solving it entirely. I'll be fetching the value from my DP table or something like that, and I'll be returning that value. So that would save my time. Tabulation. Yes, exactly. So I'll be memoizing the solution. Okay. So the memoization, how can we do the memoization? So the memoization can be done that whenever you are making a function call for some n, k and some value, what you will be doing for this n, for this k and for this sum, for this combination of n, k and sum, you will be storing its value, you will be storing its answer somewhere. So for that you can use a 3D array. You can use a 3D array in which, let me give you the visual idea of the 3D array. So this is our 3D array. Okay, so see this is the front view. Okay, this is the front view. Over here the number of rows will be denoted by the number of elements you have. You have n different elements starting from 1 to n. So the actual size or the number of rows will be n plus 1, because the element ranges from 1 to n, and the indexing will be from 0 till n minus 1. So I'll be keeping the total number of rows for this table equal to n plus 1. And now where will I keep the size of the group? Let's say I'm uh, giving the column number as the size of my group. And what can be the size of the group? The group can vary from size 0 to k. So the size of the row, the number of column needs to be k plus 1. So I can get an index for a column that will be equivalent to k. So the number of columns, I will be keeping it as k plus 1. 3DDP is required. Yes, it is required because you over here, if you observe, there are 3 different values which are constantly changing. It depends upon the number of values that will be changing while making a recursive function call. If you observe n, k and some are, these are the 3 different values which are changing. If there would have been only 2 values that were changing, then you can use a 2D array or a 2D DP. Was it clear, code camp? This is time taking question. Okay, so it will take a little bit of a time memoization, and then from memoization a quick uh, transition to our iterative approach for this as well. So this is the front view, row number, column number, and if I draw the, let's say, let me draw the top view. Okay, so the top view says that it is an entire cube. If you observe from the top, if you are observing from the top, here is your column number. This is k plus 1. This is total number of elements which you can get, n plus 1 number of elements. And over here at each and every cell, you are going to have a length of, let's say, this will be your total possible sum. This will be your sum. Let's say I'm giving you an idea that if this is a cell, and if this denotes number of element, if this denotes the size of the group, then at the backend side you will be having in this manner. And this each and every length, this length will be equivalent to your sum. You can interchange the row, you can interchange the number of, like, let's say you can keep k over here, n over here, or sum over here, it does not matter. But this is the visualization. Was this visualization clear? For 3D DP it's little bit difficult to understand in a 2D plane, but was it clear? Like, did you get an idea how we are going to store the values? A quick reply in the chat box, a +1 if you were able to understand, because it has got 3 dimensions. Yes or no in the chat box? Okay, so I need a 3D array. So what I'll be doing, I'll be having 3 different values, n, k, and sum. And what will be the size of this each and every column, row, and for each and every cell? So this will be n plus 1, k plus 1, and sum plus 1. So let me call that array as dp array. It is a 3D array, and I'll be assigning it. I'm using the syntax of Java, so I'll be assigning it the size n plus 1, k plus 1, and sum plus 1. Okay, so this is the dp array, and over here in this dp array, at each and every particular cell, I'll be storing the value for different combination of n, k, and sum. So how can I do that? Over here I'll be adding that part at each and every position where I am returning something. I was returning over here, so I'll be adding that condition over here, the dp of n, k, and sum will be stored over here, and that value will be returned. Similarly, at this point as well, I am returning something, so let me add that part over here as well. So same thing, dp of n, k, and sum will be stored over here, and that value will be returned. Okay, over here as well I am returning. For 0 I am not returning anything, because I know that I'm going to initialize that some of the values as, let's say, -1. So for 0 it's not required, so I will not be returning anything. So return dp of, not dp of, but first of all we need to store the value n, k, and sum is equal to 1. I was returning 1, but that value will be first of all stored, and then and only then it will be returned. Is this part clear? The memoization part, was it clear? Yes or no in the chat box? You can wait. You'll be getting the entire solution after memoization as well. And after memoization, I'll be helping you. I'll be explaining you how to transition into simple loop structure. Okay. So after this as well, you can code down the solution. And if you are interested more, then you can wait. I'll be explaining the iterative approach of this as well. Sir, I am at my first year and I have not started DSA in CPP, so I should focus on DSA, or I should invest my time. Geek for geek problem of the day. First of all, invest in learning concepts. learn a programming language, then and only then switch to DSA. Okay. So problem of the day, if you are solving questions, that's really interesting. That's really good. Sorry. Okay. So, but first of all, clear your fundamentals. Okay. So that's important, and DSA is the fundamental. This problem of the day are important as well, but over here, if I'm explaining a variation of a standard problem, then you won't be able to understand. So first of all, focus on standard DSA. Is it necessary to save the values in the table for base cases? Okay, so it's not kind of necessary, but it will be like more explainable if you print the entire. If you print the entire DP array, then you will be able to understand where which position you are getting the answer. So for that and only that uh, thing you are required to store. Okay, you can store it because over here, if you are not storing for this base condition, no, there are no recursive function call made from this base condition. If you don't store as well, then in the while checking the DP array, if you don't find any value as well over there at that point, then you will be getting the answer in constant amount of time because there are no recursive function call for these base conditions. So I have just shown over here that you can write down, you can store the values for simplicity. Okay, and now here comes one of the check which we need to place in the beginning of the function, that if the solution for n, k and sum is already available, then utilize that sum, then utilize that value. So what I'll be doing, I'll be adding that value, I'll be adding it over here, that if the value of n, k, sum, if the cell is not equal to -1, that if the value was calculated, then return that value. You don't need to solve it completely. You don't need to make recursive function calls again and again. Just fetch that value from that position in the DP, in the tabulation. Is it clear? So it looks kind of messy. Let me clear it out a little bit and it will be good to go. Is it clear? A quick confirmation in the chat box. Can I get a confirmation? Can I get a confirmation from everyone? Yes or no in the chat box. At least I can expect a confirmation. Yes. A yes or no in the chat box. Okay. Rishit says clear. Okay. So this is the entire memoized solution. You can code this solution and you will be getting the submitted, accepted notification. Yes, as well. So this is the entire solution. Why this solution will work? So let's find out the time and space complexity. Okay. So if you want to know the time complexity, first of all, you need to know how many values are there in your table. So how many values are there? The size of the table is what? N plus 1, k plus 1 and sum plus 1. So how many cells are there? So you can take the number of cells equivalent to n into k into sum, ignoring plus 1. So this many cells are there, and according to the memoization, no cell will be visited more than once. So how many total number of cells are there? You will be visiting each and every cell, but not visiting the cells more than once. So in total, n into k into some number of cells are there. I can write down this sum. I can replace this sum by n. So that means n into k into n, or you can say n square into k number of cells are there. So this many times you will be iterating, and this many times you will be filling these cells. Total number of cells will be iterated. So that means the time complexity comes out to be order of n square into k. I repeat, the time complexity is order of n square into k for this memoized solution. Is it clear? Yes or no in the chat box? And talking about the space complexity, The space complexity is what? Similar. N square into k, because you have created a DP array. A quick yes or no in the chat box. A quick yes or no in the chat box. The time complexity is similar to total number of, it is equivalent to total number of cells in your DP array. That is total different combinations. Actually, only this many combinations are required, while n to the power k combinations were including the repeated groups as well. Okay, thank you, Rishit. So this approach will be working if you take a look at the expected time and space complexity. It is n square into k. So this memoized solution is going to work perfectly fine. Okay, so you can code this memoized solution as well. So again, I'll not be coding it right now because I need to explain the other method to solve it as well. So we'll be going through the memoized solution quickly. So I've created the function fun. Let me copy this over here and I'll be showing you right over here. And let me copy this DP array. So I have created a DP array, and the size of the DP array is n into k into sum, and the initialization of the DP array is done over here, and all the values will be initialized inside your DP array as -1, and from here function call will be made for nk and sum. Whatever value was given to me, I'll be returning. So let me explain this uh, part as well. So what I have done, I have created a DP array that is global, accessible to everyone in the entire code, and the size of the DP array is n plus 1 plus n plus 1 plus k plus 1. So that means I have taken sum over here. The column denotes the sum, and the row denotes the total number of elements. Okay, and what I have done over here, I have initialized each and every cell as -1. You can interchange these values, but while making function call, keep it in the same manner as your DP array initialized. Okay, so function call is made. So function call is made with n, k, and sum. And now here is our recursive function. If the value has already calculated, then directly fetch that value and return it. If you reach a condition where you are getting a valid group, that means total k is equal to 0 and sum is equal to 0, then that means you will return 1 and you will be storing that value as well. And if that means if k is equal to 0, that means no uh, the size of the group is entirely 0, and you can include that if no element is remaining. If there are no elements remaining and the size of the group is equal to 0, then in that case you can return 0, and you can add the condition with both these, that if the sum is not equal to 0 and n is equal to 0, return 0. If k is equal to 0 and sum is not equal to 0, return 0. So this condition will return 0. And now including the element in the set, if n is lesser than or equal to sum, what you will be doing? You will be making a function call with that same value, n, k minus 1 and sum minus n. And you will be moving forward. And so what you will be doing? You will be excluding that element. Sum should be n in the function calling. Yes, sum should be n in the, yes, sum is not a variable, but it's a variable of this function call. So what you will be doing, first of all, you will be including that element as it is, and then you will be excluding that element, and you will be not including it in your sum. You have two different choices. Is it clear? And then both the values will be added and it will be returned over here. And if you are not including that element in the sum, in the set, you will be simply decreasing the value of n, keeping k and sum variable as it is. And after all the recursive function calls are made, you will be returning that value from this count ways to divide function, and this will be returned. So this is the entire memoized solution. Is this solution clear to everyone? Is this solution clear to everyone? Any doubt in this part? Any confusion in the solution part? Sorry, I think something, I accidentally clicked the stop sharing button instead of hide. Okay, so this is the entire memoization part, and let's try to compile and run and see if we have any kind of errors or not. So no compilation error. Let's try to submit and see. Okay, and the problem was successfully submitted. So from this, we were able to memorize the solution and we got an completely acceptable solution. So what we can do further, if we want to write down an entire algorithm without using any kind of recursion, we can do that as well. We can use simple for loop as well. So from this, I'll be converting the entire solution to iterative approach as well. We can convert it into iterative approach. Okay, so no recursive stack will be occupying the auxiliary space. So if you want to convert it into entire iterative approach, what you can do, first of all, you need to work on the base condition. So first of all, this base condition will help you to initialize the values into your entire, let's say, stack, into your entire DP array. So how will that help you? So sum of the value is equal to 0. Over here, it was not sum, it was equal to n. So some of the values are already equal to 0. For that values, the answer is not at all possible. Okay, if the answer is not at all possible, then what I'll be doing? I can use that as my initialization step, right? And for some of them, the answer is already possible, that if the sum value is equal to 0, then for whatever n and k, obviously the answer is going to be 1. And whenever the sum is equal to 0 and k is equal to 0, the answer is always going to be equal to 0. That means you obviously have one group, and that group size is equal to 0, nothing is present, and the sum of that group is equal to 0. Then obviously you are going to get one valid group from this, right? So this will be your initialization step, right? So what you can do from this, I'll be simultaneously writing down the solution. Okay, so the base condition was this, that if your sum value is equal to 0 and if your key value is equal to 0, then obviously every time the answer is possible, because your group contains nothing and you are saying that group sum is equal to 0. Then how many groups are possible? Then it is possible I can include that group. So what I'll be doing, I'll be iterating over my DP array, and according to the coding part, we kept the sum to be column number. So I'll be adding it over here only, sum plus 1, and over here k plus 1. So it will be easier to understand. So for every n value, this condition will be helping us to fill that cell with value 1. When your sum is equal to 0 and your k is equal to 0, that means the column number 0, and at each and every cell for the different k values, when k is equal to 0, you will be initializing it to 1. So I'll be iterating over all the different values for int I is equal to 0 to I is lesser than or equal to n, all the values of n, and I'll be using the DP array. The first row number signifies the element I, and these two values will be equal to 0 because sum and k needs to be 0. For that, the answer will be always 1. So this is the initialization step. Is it clear? Yes or no in the chat box? A quick confirmation in the chat box. I'm at my first year. Do you have any roadmap for me? What should I learn and focus on? I'm trying very hard to attempt regular problems. and 90% of the time I am able to solve. If you are able to solve 90% of the time, then I think you are like really good at problem solving. Then you should focus on keep on consistently solving problems. Then you can switch over competitive programming after covering all the DSA topics. Okay, there are lots of DSA topics, cover all of them, then do standard problem solving each and every day regularly, just like POTD, and then simultaneously switch over CP. That would be my guide. As you are still in first year and you are able to solve the 90% of POTD, then that's really a good progress. Okay, the way you are learning, that's really great. So eventually start shifting to competitive programming. Okay, try to explore after covering all the DSA topics. Okay, after covering all the DSA topics, and at least try to solve first of all 400, around 400 to 500 questions. What's happening here? Okay, so try to solve around 400 to 500 problems, and then you can shift to competitive programming. Okay, that would be my guide for you. And then simultaneously you can do web development on and project making. So I have converted the base condition into an iterative way, right? In iterative manner I can use this. And what I'll be doing now, I need to convert the entire recursive function call into iteration. Okay, so this is going to be very interesting. So first of all, how many iterations are required? I can see n square into k. So that means I need to iterate over each and every cell of the DP array of the tabulation. So clear content. Okay, so was this clear? Was my guidance to roadmap clear to you? Any confusion in that part? So you need to iterate over each and every cell. So I can use simple for loop, three nested for loop to iterate over each and every cell, right? So I can write down three nested for loop. So the outer for loop will be iterating over the rows I is equal to 0 to I is lesser than or equal to n. Okay, so the inner one will be iterating over the sum. So j will be equal to 0. I can write down from 0 as well, and I can start from 1 as well. J is lesser than or equal to sum. Actually, for n, I should start from 1. Okay, so the element 0 is not included. Only the elements, positive elements are included, right? And the another for loop will be for the value of k. So I'll be using the loop variable as L. So L is equal to 0 to L is lesser than or equal to k. Okay, so these are the different combinations of n, or the element, the sum, and the size of the group. So now this same condition, that I can include the element or I can exclude the element, this condition can be written down. Okay, so let's convert it. So over here I denotes the element. Okay, so what I am saying, if the element, that is I, is lesser than or equal to sum, lesser than or equal to remaining sum, so sum is denoted, remaining sum is denoted by j. If this is the condition, I have two options. What is the option? First of all, I will be storing the value. So n, k, and sum. That was n, sum, and k, right? We have changed this part, so I need to change it over here as well a little bit, because I took the column number as my sum. Okay, so this will be my sum, and this will be my k. This will be my sum, and this will be my k. So dp of sum and k. So that would be I. First of all, n, that is the element, the sum, that is j, and the size of the group, that is k, is equal to what? It is equal to this two function call. So that would be what? Dp of n, that means the element remains as it is, k minus 1, that means the size of the group decreases. So the size of the group is denoted over here for us, and not is, it's not k, the loop variable is L. So L minus 1, and the sum value remains n minus 1. The sum value is decreased by n. So sum is denoted by j, and what is the element denotation? Element is denoted by a. It is denoted by I. J minus I. Similarly, I can convert it in this manner over here as well. this part I can convert it as well. So that is n minus 1, that is element minus 1. I is the one representing element. K minus 1 means the size of the group will be reduced by 1, and the sum will be reduced by the element. So j minus I, and the size of the group will be reduced by 1. So k minus 1. Okay. Was it clear or not? Yes or no in the chat box? And now the else part is that if the element cannot be included, so else the element cannot be included, then same thing, that dp of I, j and l, that is the element, this over here, is equal to nothing but dp of element, the previous value, I minus 1, that is element minus 1, and the size of the group remains as it is, the sum value remains as it is. So j and l as it is. What about the other base case? Other base case is not required now. It is not required because whenever you reach such kind of condition, this will be helping you to fulfill the part, because see, you will be initializing the entire dp array in this case using 0. Okay, you'll be initializing the entire dp array by value 0 in this, while in the memoization you need some value as minus 1, because you need to see whether it was visited or not. Okay, but 0 can be the answer for some test case, hence you cannot use 0. Okay, so this was the part, and over here you can do it in this manner, and this is the entire end of the for loop. So this is the entire iterative approach to solve this. Was it clear? Yes or no in the chat box? Okay, so now let's see over here the entire tabulation part. If I code it, it will be taking too much of time. So in the tabulation part, let me remove these comments. So we have already submitted it. So let's remove it and add it over here. So this is the entire function. So the function is, first of all, I have taken the dp array. Okay, so dp array was required, and then initialization with n plus 1, and k plus 1. Okay, so this is a reduced code, and now the initialization is done for different values of n, and the sum and k will be equal to 0 in this case. And what is the value initialized? It is initialized as 1, and then I'll be iterating over different values of n, different values of sum, and different size of the group. If I see that the element is lesser than my remaining sum, then I will be including that element, and this is the conversion into our recursive function call was converted into entirely a mathematical statement. And if the condition is true, that if this is not true, that the element is greater than your remaining sum of the group, then you will be excluding it. So you will be taking the previous value and keeping it as I, j, and lth cell. And at the end, after all the cells are iterated, the value will be present as at the cell number n comma n comma k. That is the solution for this given test case. Whatever is the value of n and k, and whatever is the value of sum at that cell, your answer will be present. And if we try to compile and run, let's see if we have any kind of compilation error. Okay, and let's try to submit it. Okay, and the problem was successfully submitted. So was it clear or not? Any doubt in the part? It was earlier sum is equal to 0 and k is equal to 0. Was it the case? Sum is equal to 0 or k is equal to 0. See, I explained, no? See, if you have different condition, that when can the answer be not possible? When your n value is equal to 0 and your sum value is not equal to 0, then answer is possible, that it will be 0. Or when can be the sum be when can be the answer 0? When your sum is not equal to 0 and your k value is equal to 0, that the size of the group has been exhausted, but the sum of that element is not equal to n, so we'll be getting 0. And is there any more condition possible? So the combination of these two will give you that if n is equal to 0 or k is equal to 0, you can simply return 0. Okay, yes or no, clear or not? Yes or no in the chat box. Was it clear? Yes or no in the chat box. One more question. Could you give the intuition for the test case for the brute force approach? So the intuition was that for the brute force approach on a test case, first of all, you need to identify. You can think in this manner that these are the possible number of choices. Okay, from this I can choose any of the element, and I need to form a group. I need to form a group that contains k number of elements. So I have k different positions available. Okay, and how many elements are possible at each and every group? So I can see over here n number of elements are possible. Okay, so can I include the element again and again? So I came to know, okay, I can include. So I came to know that I can try out this kind of condition. I can try out this kind of algorithm in which I'll be trying out all the groups. So I came to know that if I want to generate all the group, it is basic that if I want to find the subset of an array, then I used this approach that I have two possibilities, that I can include the element or I can exclude the element. From that, you can understand that, okay, recursive function is required, and that recursive function will try to help me find all the different groups possible by trying out all the possibilities, and in that way you will be reaching a recursive approach, and a recursive function will be in your hand, and then you will be trying to memoize it, and then you can tabulize it. Okay, I sorry. I mean the complexity. So the complexity part already explained, no? You are trying out every possible combinations, right? You are trying out every possible combination. You can include the element. See, I can create a group that contains all the same integers, right? So that means total how many combinations are possible. I can try out this many number of combinations. So that is n to the power k. Okay, was it clear, Rishit? Time complexity n to the power k. Okay. I feel helpful, like if I'm able to clear all of your doubts. Okay, so this was the entire solution, and I'll be sharing this link as well. So let me share this link in the chat box. Okay, so you can refer to this as well as a companion. And if you are coding in C++, a simple modification of functions and all that is required, and you will be able to convert it into C++ as well. Okay, so there is only a syntax difference. So that was it for today's session. I hope you really enjoyed the session and you were able to understand the entry solution in a good and informative way. Okay, so this was a basic modification or a variation of a standard problem, and that was it. If you already knew the standard problem, then you might have figured out the way to solve it. Okay, so that was it for today's session. Do you have any kind of doubt? I'll be waiting for 1 or more minutes. I'll be happy to take your doubts. If you have any, then please do share with me. 1 hour for such a question. Okay, so I think it was better to go in this manner. So I take time, I know, and that's okay. So you will be getting a proper understanding. That's the reason for taking such a time. Okay, so I think no one is having any kind of doubt. So we'll be ending the session here only. It was great interacting with everyone. So do like the video and share it with your friends if they are doing the same kind of DSA thing which you are doing. And so let's meet in the next POTD. Okay. So best of luck for the upcoming POTD. Thank you everyone. Bye bye. Good night.